In this video, we'll learn how to find for a specific term in a binomial expansion when we are not given the term number. Let's see how we can do this by considering this problem over here, where our task is to find the term independent of x in this expansion. But before that, we need to understand what the term independent of x means. This means that we want to find a term that does not have x in it. Basically, we want to find a constant term. And let's call this constant term a. And this term will be of the form a times x to the power of 0, because x to the power of 0 is just 1. And what's important to note is, this x to the power of 0 term will occur at some value of r. The problem is, we don't know r. But we need to find r before we can find the term independent of x. So how do we find the value of r? Remember, the general term is given by this. So we first need to find what is a, b, and n. The first term in the expansion is 1 over 2x squared. So a is equals to 1 over 2x squared. The second term in the expansion is negative x. So b equals to negative x. And the power of the binomial is 9. So n is equals to 9. To find r, let's substitute these into the general term, and it becomes 9 choose r, 1 over 2x squared to the power of 9 minus r, and negative x to the power of r. Remember, we're interested to find the term independent of x, but in this expression over here, we have x terms here and here. So let's simplify this expression such that all the x terms can be written into a single x term, and all the terms without an x can be grouped together. When we simplify this, we get 9 choose r. 1 over 2x squared can be rewritten as half times 1 over x squared. So this entire term can be rewritten as half to the power of 9 minus r times 1 over x squared to the power of 9 minus r. And negative x to the power of r in a similar way can be written as negative 1 to the power of r times x to the power of r. But notice that we still have x terms here and here. So we can rewrite the expression like this, where all the terms without the x is over here, and all the terms with the x are over here. Notice that we expressed 1 over x squared in negative indices so that the bases are the same. By the law of indices, we can simplify these by just adding the powers, and we have this. Now, to find the term independent of x, we are finding the term containing x to the power of 0. This means that x to the power of negative 18 plus 3r is just equals to x to the power of 0. And solving this, we will find that r is just equals to 6. This tells us the term independent of x occurs when r is equals to 6. So we can find the constant term by putting r equals to 6 in any of these expressions over here. But let's use the last expression because it's in the most simplified form. So t6 plus 1 is equals to 9 choose 6 half to the power of 9 minus 6, negative 1 to the power of 6. And if we put r equals to 6 into this term here, we will get x to the power of 0. Using a calculator, the seventh term is equals to 10.5 times x to the power of 0. And since x to the power of 0 is just 1, the term independent of x is 10.5. And this is how you find for a specific term in a binomial expansion when the term number is not given.